Okay.
Let's start. Alright. Have you all read or watch? Have you all watched the videos from last week? I uploaded. Any questions on that lecture? Let me see what I talked in that lecture. Kind of forgot. It's a responsibility-driven design. PowerPoint. Where design software. Oh, okay, yeah. I'm talking about applying the object-oriented principle to that Guitar Shop system and make it extendable, maintainable, right? Okay, any questions on that part? Not here, not here, not here. Delegation. Okay, where is it? I'm talking about the step 2 and 3. It's not here. Okay, it's on the book. Let's review a little bit. Make your software does what the customer wants it to do. Apply basic OO principles to aid flexibility and strive for a maintainable, reusable design. So what do you remember? What do we do in step 2? In step 1 is in class. What was that?
We apply object-oriented principles.
Yes.
We introduce enums.
Oh no, that's enums, and return a list. That's step 1, if you remember. Step 2 is what I mentioned in the video. If you watch that video at
I
home.
didn't finish it.
We started to watch
apply the names. To apply to do what the names pointer.
Name?
Names or object. What the object pointer.
Pointer. Did I mention a pointer?
You mentioned
That's first step. Second step. Oh, that's first step. Yeah, step 2. What I do is I want to keep the object to do what it is supposed to do. Do you remember? I mentioned that a lot of times in the video. So I want each object to do what he's supposed to do. And whatever he's not supposed to do, you need to either separate another object to do that or delegate that to another object or class to do that job, right? So, and we did some modification to Rick's Guitar Shop, like here, guitar specification, right? Because we were using they were using the guitar object to do the search task. But actually, when you are search, you are not really having that guitar. You only have a specification of the guitar. So we create another new class called guitar specification, and we move some attributes specification to guitar specification, so that we keep we're following the rule of the object-oriented design, right? We want the object to do what it's supposed to do. Yeah. So when we're doing this step, it seems not a whole lot of benefit there. But when we reach the third step, you will see, right? You will see how easy is it when we want to actually reuse the code and extend this code. So in the third step, what we do is we want to add a new 12-string guitars. We want to add a 12-string guitars. If in the old design, if we do not have the guitar specification, those kind of things, okay, then what we can do is we basically need to modify all these classes there, including guitar, including inventory, including this specification. Everything there needs to be changed, okay? Because if we want to add a 12-string guitar, that means a new model, a new type, okay? And that means we need to change the search function, because in the search function we need to compare this parameter 12-string, okay? And number of string, when we need to change the guitar class, because when we creating this new object of a guitar, we need to specify how many string there is. Okay, so that changes the constructor, changes the original constructor. So too many changes there. Okay, if somehow you find when we're adding a guitar, adding a 12 string, maybe later on you added 16 string, a lot of string, 100 string. Okay, so those kind of guitar, so you can anticipate that this will happen a lot. So when you say, you want that change may happen a lot, and then that change may have an influence on every single class or most of the classes. That is the time you need to think about to put that change, to isolate that change itself as a separate class. Okay. So what we do here, instead of change everything, we encapsulate the specification and isolate them. Okay, here in the constructor, so this is the old constructor. Clear? Is it clear? Okay, so yes, we specify everything here, and we create a new specification with a new guitar specification object with this specification information. That's the old way, but a new way to do this is this. Oh, I'm sorry. This is actually Yes. A new way to do that is instead of when you're creating a guitar object in the guitar class constructor, instead of specifying everything, we use guitar specification, this object, to specify all the information. We encapsulate. In other words, we are doing encapsulation with this guitar specification class. This class contains all the information of the guitar. So when we creating this guitar, we create that guitar with the guitar specification instead of creating the guitar with builder, string type, number of strings, back wood, top wood. Understand that part? So we add a layer there. That can encapsulate all the change. So later on, if you want to have more information, change the guitar specification with more information. Like this time is number of strings. Okay, maybe later on you want to add another parameter, like the manufacturer. No, not manufacturer. Okay, where is this guitar made? The country. It's a guitar made in different countries. Okay, so if you want that information, you can do it here, just modifying this guitar specification class without touching the guitar or without touching the inventory. So that's the ideal solution for this kind of situation. When you want to do a change, you want to do it only in one or fewer. You want to do the change. You want to do the change in only one of the class. That's the most ideal situation. But sometimes maybe it's 2 or 3 class. That's fine. But not that if you want to do a change, you want to touch all the class. That will give you a lot of trouble. Okay.
So how,
You try to minimize the classes you need to modify whenever you want to make a change. What's your question?
Yeah, with guitar spec, how does guitar class change to this additional class?
Yeah. So let me show you. So this is the guitar specification change. Okay.
Yes.
The change is we move every information to this guitar specification in the
Yeah.
constructor. Okay. And later on, see here, guitar.java. That is a public guitar. That is a constructor. You see the difference? We only specify the serial number and price, and then guitar specification. Okay, we're creating this guitar object with an object of guitar specification instead of specifying everything. Okay, then when we do the change, we just need to do the change in guitar specification without touching the guitar. Got this point, everyone? Yeah, ask if you are confused. And we also change the search function here. Okay, if you remember the old search function, is we're comparing everything, right? Model, the price, or the model, the wood, the material. We're comparing everything in the search function, right? This is a new search function. We do not do the comparison here at all. We're doing the search comparison in the guitar.getSpecification.match. Okay, in another word, we add another match function to the guitar specification. So that everything is encapsulated in the guitar specification. Okay. So a benefit of this is obvious when we're trying to add a 12-string guitar, or later on when we're trying to add the country of the guitar where it is made. We don't need to care about guitar class. We don't need to care about inventory class. We only need to modify things that within this guitar specification class. We only need to change, maybe we add another if statement to compare a new information. But everything is done within that guitar specification class. Okay, so that's how we reach the reusable and maintainable with object-oriented design. Okay, but if we do not have the second step, we do not apply this OO principles, which the most important one is the object, the class, does what it's supposed to do. Okay, if we do not apply this principle, we're not able to do this third step. All right, or in this third step, the idea behind the third step is the change. Define those change and anticipate what's possible change you may need to make in the future, and then you isolate the change into a separate class or separate module. A module may combine with several classes, but just isolate them. You do not want a change to have influence on the whole picture. Okay, that's the idea. Remember this. Yep, I like this example. So that's the what I was talking last week. All right, let's talk about today's material for this week. All right. One thing. First step is, so we have 3 steps. The very first step is do whatever the customer wants it to do. The system should at least do whatever the customer wants it to do. Otherwise, it's a fail. It fails. It's a failure. Okay. Can somebody use the shade? Okay. Thank you. Thanks. Do whatever. Yeah, it's working. Do whatever the customer wants it to do. That's basically referring to the requirement, right? Requirement from the customers. All right. So in this week, we're gonna talk about the use cases, which helps you to generate all these requirements for your system. Okay. All right. So this slide seems pretty old. Yeah, you can tell from the background, this design. But what classic is still classic. What useful is still useful from that time. Let's look at this. So in this case, so a university wants to computerize their registration system. So they want a registration system. Okay. So all the cases here is regarding their registration system, which we are pretty familiar with. So the register. Here's some basic thing about this system. First, the register sets up the curriculum for a semester. Okay, and students select 4 primary courses and 2 alternate course. That's 6. That's a lot, right? For maybe it's undergraduate. Yeah. Once the student registers for a semester, the billing system is notified to the student for the bill, and students may use the system to aid and drop courses. That's the basic functionality we want. And professors use the system to select courses to teach and request the course rosters. Yeah. And yeah, password and logging verification, log on validation. So that's a general registration system for a university. Okay, when we have those simple description of what we want to do with the system, first thing we can do is to identify the actors of the system, right? So the actors is someone, something that must interact with the system under development. So okay, so we do have all these rules we described. And building system. These are easy to understand. Okay, we have student, professor, and register. How about this building system? Is it actor? Do you think that's an actor? Yeah.
Because it's external to the system.
Yes. So actually, this building system is the system that is already there, and the new system you are going to develop needs to interact with this old system. Okay, this building system. So that kind of work as an actor in this current system. So the actor can be a person, or a system. Remember that? Yeah. Actors are not part of the system. Yeah, it's something outside, but it has an interface to interact with system. So what the actors do is input information and receive information. So it's in and out from the system. Put in something, get out something from the system. And it's not necessary that okay, the system can do like only input or output. That's okay, and or it can do like input and output. So yeah, it's not necessary that it should do in and out together. Okay, you can just get something out, or you can just put something in. Okay. So we were trying to identify the actors in the system. So here's some questions you want to ask yourself. You want to ask when you are analyzing your system. Okay, first, who is interested in a certain requirement, like the registration system? Who is interested in selecting courses? Selecting courses to teach the professor, right? Who is interested in register for course, aid course, drop course student, right? So you ask this question, you identify, okay, yeah, professors, students, they are actors of this system. Second, where in the organization is the system used? Where in the organization is the system used? So the registration system maybe is in the registration department. Okay, so who in the registration department is using that? Right? Okay. Who will benefit from the use of the system? Probably like everyone kind of benefits. In this case, professors, students, the registrar, they all benefit from that. But when you see this system, you can tell that student can aid and drop. So students can do it more efficiently. Student can benefit from it. So it's professors, right? And who will supply the system with information, use information, and remove the information? So this curriculum setup, this means provide the information. Students use the information. And students also remove some information, maybe drop something like that. Okay. And who will support and maintain the system? You may need an administrator there. Or if a system do not need an administrator, maybe as part of the maintain job belongs to the professor or somehow. Okay, so but who will support and maintain the system? Obviously, it should be another actors. Okay. So if you think about a game. Okay, think about a game. Somehow in a game you have some players who have a superior rights above all the other players. Maybe he paid a lot of money, maybe he's an administrator, but that's a different rule, so take that into consideration. And sometimes it's administrator, well, okay, in the game maybe some player do not behavior quite well, you have to delete their account, something like that, right? And in the school system, yeah, we may want to have some administrator there to help us manage the system. Okay, and then does the system use an external resource? Does the system use an external resource? Maybe if that's an external resource, somehow it can be two different things. First is use, the other one is extend. Okay, like use is the system is using the functionalities from other system, so so the other system needs to provide some information to the system, otherwise this system won't work. The other thing is extend. Okay, extend means this system only provide some information to another system, maybe provide some information for the billing system. The billing system is not really using this system. Okay, so this works as an extend for that billing system. So that's two different kind of interaction between systems. Okay. External resources. That's one person plays several different rules. Do several people play the same rule? So that's all we want to consider. Does the system interact with the legacy system, like the billing system? Okay, so the billing system is an actor there. So all these questions is to help you to identify your actors. But most of the time, this part is not that hard, right? Just remember a system can be an actor as well. Yeah, that may be a little bit confusing because that's called actors, right? When you develop system, I think it's pretty easy for you to identify the actors. Most of the time, the client just specify, I need to use that. The HR department use that. The client use that. Yeah, but what you want to identify is maybe in the HR department, people are using that. They are in different rules. They're different actors. But the client, maybe they're different kind of client, something like that. So this is things you want to ask and think. And use cases. So what is use case? Have you all played with something like use case diagram before? That's pretty simple, right?
Yeah.
Just an actor and a line and a case. That's it. Okay. But use case is different from use case diagram, right? Here I'm talking about another different thing. Use case is an abstract concept that just describe how the user uses the system. Okay, it's a sequence of transactions performed by a system that yields a measurable result of values for a particular actor, for a particular vector. So it's a concept here. It's a sequence of transactions. All right, it's not just a use case diagram. So each use case is a sequence of related transactions performed by an actor and the system in a dialogue. So it's a sequence. Okay, so when I want to finish this registration, I need to first log in, and system verify the login information, and let me in the system, and then I need to search and select the information. I just search. I need to identify the range, and system returns some information. Then I select the course and submit for the system, and system register those courses for me. Okay, so that's a sequence of interactions, right, between student and the system, right? So that's the sequence. And the case typically represents a major piece of functionality that is complete from the beginning to the end. Yeah. And a use case must deliver something of value to an actor. Yeah. Like this, those two are the name, only the name of the use case. Okay. It's not like when we are trying to draw a use case. Oh no, when we're trying to specify use case, you cannot just do it this way. It's an oval and some description. And it also describes a desired external system behavior from point of view of the user, and that's the requirements that the system should fulfill. Okay, so yeah, it's similarly the interaction between system. We need to describe it, and it is a description of what the system must do, but not how the system does it. How the system does it is kind of algorithm or implementation, something like that, right? So a use case is an individual step, but the largest possible related process, yeah, not individual step. And yeah, chronologically related process. So it's in kind of in time order. Like I first do this, the system return, then I do something, blah blah blah. A use case describes a process. Yeah, use case diagram is not. Yeah, and the use case is a pattern of behavior the system exhibits. Each use case is a sequence of related transactions. Okay, so basically everything is mentioned here is telling you use case is a sequence of transactions that we describe what happened when we want to finish some functionality, registration, something like that. Yeah. This is the important part, that documenting a use cases. So a flow of events document is created for every use case. Okay, whenever you find this use case diagram, you have all this simple description of the use case. Actually, for each use cases, ideally you should have a document for each individual use case. And how do we document that? Is remember this part. This last three part is basically the three sections of a use case documentation. One is normal flow, one is alternative flow, one exceptional flow of events. Okay, so you can tell what are included in each section, right? Let's look up this when and how the use case starts, that's in and end. So every use case has a way to start and end. It won't like last forever. And what interactions are there, and what data is needed. That's the thing you want to explore. That's the information you need to create this when, what. That's the information you need to create a use case documentation. And these last three, normal, alternative, exceptional, is the three sections you want to include it in your use case, documentation, right? So what is normal? What is alternate? What is exceptional? Normal is like, yeah, I think you can understand that. Normal is like if I want to register for a class, a normal case, I log in, right? I search, I got return. and I select a course, then I register for that course, right? That's a pretty normal process for registration. An alternative flow of registration. Maybe I log in, okay. I do not do the search. I maybe there's a pop-up tells me you need this course to graduate. Okay, maybe I do not do a search. I get this course information, or I know which course I'm gonna to register for. So I just type in this. That's also a search. I can type in this course number and just register for that. That's an alternative, but that's an alternate flow, right? An exceptional flow. We should get some arrow, right? The course I'm searching for a course that offered 2020. Okay, so that's not in the system yet, right? So I get some arrow. That's the exception, right? So that's the exceptional flow of events. So that's basically the 3 parts there. Right. Okay. Select the courses to teach. We will have this example, flow of events for the selected courses to teach use cases. Okay, so I have all the answers there, but first I want you to have in-class exercises. Just do this select the course events, divide them into normal, alternate, and exceptional flows. Okay, I want you to do it in the class, and then later I will explain the answers in the slides. Then I want you to compare your answer to that answer, right? So that you will know what is needed in that. You will have a better understanding what is needed in this use case documentation. Okay. Now please start to this flow of events. You can use your computer. You can take a piece of paper. It's fine. It's not going to be graded. It's just I want you to have a. So right now you have an idea of what it looks like. So I want you to write it down your idea and compare it with this kind of standard way of documenting. Then it will bring your writing style closer to the standard way. Okay. So let's do that. Let's briefly do that in like 5 to 10 minutes. Okay. Of select courses, select courses to teach. Sorry, it's select the course to teach. It's in the scenario of a faculty. Okay, so right now what I just explained is register for a course. Select the course I want to take. Login, search course, and blah blah, things like that. But now I want you to do this flow of events for the select courses to teach. That's from the actor of a faculty.
Okay.
But you need to include normal flow, alternate flow, and exceptional flow. Probably most easy one is the normal flow. Okay, let's look at how the standard answer is, what the standard answer is. Okay, let's see if you miss any information compared with this standard documenting. First is preconditions. Of course, yeah. So when you're describing a use case, you kind of want to include these sections, like the selecting courses. It should have a precondition that the course has been inputted already. Okay, let's look at the main flow. That's all the main flow. Okay, so how to describe the main flow? Example: this use case begins when the professor log on to the system and enter password, right? Log on. The system verify the password that is valid, okay, and prompt the professor to select the current semester or a future semester, right? And the professor enters the desired semester. The system prompts the professor to select the desired activity. So add, delete, review, print, or quit. If the activity selected is add, then add a course offering subflow. And that makes sense. So all this, they create this 4 subflows for this main flow. Okay, so subflow is basically add, delete, review, and quit. Right. So you can see here what is E1 and E2, S1, S2, S3. S here in this documentation means the subflow. Subflow 1, subflow 2, subflow 3. E1, E2 is the exceptional flow 1, exceptional flow 2. Why do we have exception flow here? It's valid. Yeah, that may be an exception there. It's invalid. Okay, and E2,
For future.
future semester. Yeah, maybe you select a semester that doesn't exist. Yeah. Alright, the subflow is like add a course, delete a course, review a schedule. Okay, when you describe all this, for example, add a course, the system displays the courses screen containing a field of a course's name and number. Professor enter the name and number of a course. Here, another exception may occur. Right? So when you describe all this main flow, subflows, kind of think about where the exception may occur. Okay, so here exception flow 3. Maybe you enter the name and number of a course. Maybe it doesn't exist, and the system displays the course offering for the entered course. The professor select a course offering. The system links the professor to the selected course offering. Another exception may occur. Here is so exception here may be maybe the professor has already exceeded the maximum amount of course he can offer, or something like that. Okay. And also deleting. Well, when you describe deleting, also comes with think about where could the exception occur. Okay, like E6, E7. The system moves the link to the professors. The professor enters the name and number of a course offering. Right. Again, this exception may occur. The number may not match or something. The name does not exist. And review a course. Why review a course has exception? So the system retrieves and displays the following information for all course offering for which professor is assigned. Okay. Yeah, if it retrieves no information, something like that, course name, number, things like that. And when the professor indicates that she's through the reviewing, the use case begins again. Okay. So it describes how this case ends or so. So that's the main course. So it's the main flow and the subflow. We can also call the subflow an alternative flow, right? Because when you reach some point, there are different options for you. You can add, delete, review, something like that. And in each alternative, they may have different sort of exceptions. Like the reviewing, if you're reviewing your schedule which does not exist, then we have an exceptional flow. Also, we have different other subflows like print schedule, yeah, and exceptional flow here. That's a E1. A lot of them. E1 is invalid semester entered. Okay, the user can re-enter a professor ID. Invalid professor ID entered, the user can re-enter. Invalid course number entered, the user can re-enter. Same. And course offerings can't be displayed. The user is informed that this option is not available at the current time. The user case begins again. Okay, so all these exceptions, that's hard part, very hard part of generating this document, right? Because you have to think every single details to think about, go through every single detail to think about what kind of exceptions there might be, right? But well, if you want to design a system that's a good system, you have to go through this. And exceptions, they occurs all the time in every system, right? That's how you reduce your bug. That's how you make your system robust. You can handle all these exceptions. Okay, so I believe most of you can have this main flow described, but you may miss some of the subflows, or you may, if you combine some of the subflows, that may be okay, but try to include as much information as possible when you are trying to analyze the system, analyze the requirements from the use cases. Okay, with this documentation, like flows, it's pretty clear what your system functionality, what kind of functionality your system should have, like how do you implement your system, right? What kind of design should they have? How many classes, and what classes should do what kind of job? So, and what kind of other functionality should be delegated to other class, something like that. It's gonna be helpful. Use case diagrams has relations between actors and the use cases. Sure, maybe, yeah, this student is maintain the schedule. It's doing adding, deleting, something like that. But maintain the schedule is actually giving the information to the billing system. Remember, the billing system, that's a system, not a person, but it's getting the information from this use case or system. Yeah, this use case gives information to the billing system. And the professor requests the course, register, maintain the curriculum. And this uses, okay, register for courses. They use logon verification. So logon, this use case is used by all these two: register for courses and maintain the curriculum. Another relation is called extend, what I just mentioned. So if you want like register for courses, okay, if a student wants some help, on register for courses. You may have another use cases, getting help information for register process, and this use case will have an arrow pointed to this register for courses use case, and the relation is extend. This system can exist there without this help information. Okay, but the existence of help information extend these use cases. Okay, if you want to clearly specify that relation, yeah, be careful with the direction of the arrow. Okay, when you are using another use case process, there is uses, but if some other cases, maybe sequence or transaction, those use case extend this current use case, it should be pointing from the one that extending it. Okay. Okay, so compared with what you just write down and that documentation, you find anything that is not very easy? Just compare. Yeah, what's the biggest problem of what you just documented? What is the part that you missed?
I guess it depends on if you have like the domain knowledge of that particular process. So, if you had all the tacit knowledge that's involved in
The domain knowledge, yeah, that's one thing. So domain knowledge is like you only have those assumptions of that domain. Yeah, that's okay. But in terms of that format, main flow, subflows, and exceptions, we are good with that part? Good? Okay. So when we're actually trying to write down some use case documentation, we should be able to do that. Yeah, if we're missing something, like missing exceptions, yeah, that happens, but we just try our best to include every flows there. But it's almost impossible to include everything. So we have to improve that. That's why people are developing software in an incremental manner. Right? We just keep improving. And use case realizations, use case diagram presents the outside view of the system. Interaction diagrams describe how the use case are realized as interaction among the society of the objects. Okay, so if you're familiar with UML, sequence diagram is pretty good resource to describe this kind of transactions between and false, right? Let's see. See, this is a sequence diagram. So it displays objects interaction arranged at the time of request. Yeah. So read this sequence diagram. Then which do you think is this use case? What is this use case?
course registration.
Yeah, I think so. Yeah. So yeah, it's pretty clear. First step, second step, and in the first step, what happens between which parties? Right. First is the student and the registration form. Fill in the form, submit that, and then between this register form and the registration manager, add a course. And at the course, we are trying to locate this Math 101 object and check if it's open, right? If it's open, yeah, probably it will return like open or something like that. And we add Joe, and yeah. section 1 and different section. Yeah, of course, different. If a different section has different object, you have to check with that options, and you aid the student there. Yes. So we can use one thing is implement this this use case with sequence diagram, which help you to visualize all the flows. Okay. And here you kind of have the design of the object, those classes, right? Object-oriented design. We kind of have those object design there, and then we try to figure that, okay, every time when some transactions is happening, it's happening between which two parties, and what should they respond, and should I put this, like these two objects, should I just put them together as one object, like a section is attributes in the Math 101, or should I separate them? So that's design decisions based on the scenarios you're using this system, right? For example, here a section of the Math 101, section 1. Yeah. If there's really an 8 functions there, should it be in the Math 101 or should it be in the Math 101 section 1? Given the scenario of this registration system. You can have maybe Math 101 and which Math 101 section 1 is a part of it, and you can have an 8 function there to aid it to different section. Yeah, so different kinds of design decisions there, right? Here, if we are following the principle of that, we want object to do whatever it is supposed to do only what it's supposed to do. Okay, so probably the actual 8 function should be here, because when you are taking that course, you're really in one section of that course, right? You aid that into one section. And if you're registering in the Math 101, probably there's an add function there, but I believe that's a delegation from the math to this Math 101 section 1, so that we won't keep the object do whatever it's supposed, only do what it's supposed to do. Okay. But if you have like 8 function, if you're having a aiding function from the registration manager, in this manager, you are like getting the information from Math 101, and then you are from here, from the registration manager, you are putting the student into this Math 101 student list. That probably shouldn't be there, because the registration manager shouldn't do that, right? It's not supposed to do that. So you want to identify that. Here, and the collaboration diagram is displays object interactions organized around object and their links to one another. Yeah, so that's sort of the interaction between the objects. It's similar. It's pretty similar to this. Sequence diagram. I like this sequence diagram. It's more clear. It contains more information there. Okay, so that's a use case. Okay, and next class we will learn about how can we generate use cases and use these use cases to help with our design. Okay. All right. So that's it for today. And wait, one moment. We have a semester. For this semester, we have a project, course project. Yeah, it's gonna be due at like the final of this course. So I'm asking, do you want it to be a group project or it's an individual project? Which one do you prefer? It's gonna be a design, no implementation, just design documentation.
Is it the same amount of work or different project?
Well, yes, same amount of work.
Group is better.
Group is better. Because sometimes students feel it's hard to work in a group, but here, yeah, but here I want everyone to work in a group in my class because eventually, when you get a job somewhere, somehow you will work in a group. Okay, so yeah, I'm gonna do this as a group project, and I don't want a very big group right now. So like 3 person a group. At the maximum amount of students is 3. So you can start communicate with your group. So this is both for the in-class student and online student. Yeah, online student. You can cross the section in class or online. It's okay if you know somebody online that wants to join a group. That's fine for me. But start to talk to your colleagues using the class time here, the after class time here, or using the forum in the D2L. Try to recruit your team members, and the project information, I think I posted already in the D2L. If not, I'm gonna post it later. Yeah. So only design documentation. No need for the implementation. Yeah. All right. So because this course is about design, not implementation, not programming. All right. But if you can have a decent, reasonable amount of time to do the implementation, that's okay. Yeah. All right. Yeah. Well, another thing. We still have 3 minutes, right? So I'm conducting a user study. Okay. So this is not for online. So I'm gonna stop it. All right. Bye, online student. See you next time.